Hello everyone. Today I am going to discuss one practice problem based on elimination reaction. This is the first practice problem where this reaction has been given. So first we have to explain the mechanism of this reaction. Then we have to find out the major and minor products. And there are 4 situations has been given, and that also we have to find out. Like what happens to the rate of the E1 reaction under each of the following changes in the concentration of the substrate and the base. So now let's explain it. Now we'll explain the mechanism of this reaction. So this is our substrate, and chlorine will be leaving as a leaving group. So then we are getting a 3-degree stable carbocation. Actually, we can write down the carbocation in this fashion so that we can understand the number of beta hydrogens are present here. So here we can see there are 2 beta carbon. So, and this is the beta hydrogen. One we have denoted as red in color, and second one is the green in color. Now here methanol is acting as a base. If methanol attacks this proton, that red color proton, then these 2 electrons in this bond will be moving to the positive charge carbocation, and a double bond will form here. So that means we will be getting the product compound A. Here you can see double bond is forming between these 2 carbons. Now there is another possibility where this green color beta hydrogen can remove by the base methanol, and in that case we will be getting compound B. Here you can see double bond is forming between these 2 carbons. Now we have to find out the stability of compound A and compound B, and that will tell us that which will be the major and minor product. Now stability of the alkene depends on the hyperconjugation structure. So let's explain it. Now here this is the alkene and this one is the alpha carbon. So this alpha carbon has 2 alpha hydrogens. That means compound A has 2 hyperconjugation structure. Now in case of compound B, this is the alkene. So it has 2 alpha carbons, and 2 alpha carbons has 6 alpha hydrogens. So that means 6 hyperconjugation structure. More hyperconjugation structure means more stability, and more stability means major product. So that means compound B is more stable than compound A. So compound B will be the major product and compound A will be the minor product. Now this is the second part of the question where we have to check how the rate of the reaction depends on changing the concentration of base or changing the concentration of substrate. Now since it is a E1 reaction, and E1 reaction, the rate of the reaction is depend on the concentration of substrate. Here the rate of the reaction does not depend on the concentration of base. So according to the rate law, the rate of the reaction will be rate equal to K into concentration of substrate. K is the rate constant. So now here I can write it down that this is like a first rate where the concentration of substrate is C. So rate 1 equal to K into C. So now here it has been asked that if the concentration of base is double and concentration of substrate means Rx stays the same, then what is going to happen? Now here you can see already I have explained that here in the E1 reaction, rate of the reactions depends only on the concentration of substrate. It is independent on the concentration of base. So if you increase the concentration of base, then nothing is going to happen in the rate of the reaction. It will be the same as it was. Now the next condition is that where the concentration of base is same but concentration of Rx is double. So that means in that case concentration of substrate is increasing means definitely rate is also going to be increasing. So that we can also write in that way, that rate 2 is that K into 2C. So that means we can write that rate 1 into 2. So that means that in case of this one, that when concentration of substrate is double, the rate will be double of the first rate. Now here concentration of base is double and concentration of substrate is half. So that means the same thing, base concentration is not going to affect to the rate of the reaction. But since the concentration of substrate is half now, so definitely the rate will be half of the rate 1. Now in the fourth case, where the concentration of substrate is stable and base, so same thing, concentration of base is not going to affect in the rate of the reaction, but yeah, definitely rate of the reaction will be now 3 times of the rate of the first rate of the reaction. So I think now you understood the explanation. So this is the second practice problem, where this is a substrate and here you can see one side I is present and second side chlorine is present, and CH3O minus is used as a reagent. Now if we think that which will be acting as a good leaving group, iodide or chloride, definitely iodide will be the better leaving group than chloride, because iodide atomic size is bigger. So if we think that what SN2 reaction is happening here, then iodide will be leaving as a leaving group and CH3O minus will be acting as a nucleophile and will be getting this product. But actually CH3O minus act as a strong base, so E2 reaction will be dominant over SN2. So in that case, the product will be like that. So this iodide will be leaving and this beta hydride elimination will take place and we will be getting this product. So now this product is matching with the option B. So correct answer is option B. So I hope you understand the explanation. If you want to recap your concept of elimination reaction and the Schwarzschild rule, then you can check these 2 YouTube videos which is designed by me. And thank you for watching this video. Let's practice. If you have any queries, then you can send me a mail to this email ID.